Special angles and the unit circle. So a circle is defined by a set of points that are equidistant from a fixed point called the center. The distance between any point on the circle and the center is called the radius. A circle of radius r and center 0, 0 is shown below. The point xy lies on the circle. Draw a right triangle in a convenient position and use the Pythagorean theorem to find the relationship between x, y, and r. So how might we draw a right triangle?
Draw it
Straight down from? And? So this is x, this is y, this is r. And what's the relationship between x, y, and r? Sorry? X squared plus y squared equals r squared. The equation of a circle with radius r centered at the origin is just that. X squared plus y squared equals r squared. Write the equation of a circle centered at the origin with radius 5 units. So what's it going to be? X squared plus y squared equals? Yeah, or 25. Yeah, usually if we can do something, we do it. So we don't say 5 squared, we say 25. Write the equation of a circle centered at the origin with a radius of 1 unit. X squared plus y squared equals 1. A circle centered at the origin with radius of 1 unit is called the unit circle. So you probably know all about the unit circle now. Use your knowledge of special angles to determine the values of x and y, right? So just pretend these are angles within a circle, right? And this is a radius of 1. So what can we say about cos 45, let's say? Cos 45 is equal to, in terms of x, y, and 1, x over 1. So we can say that x is equal to the cos of 45 degrees, which is, how soon they forget, root 2 over 2, right? What can we say about the sine of 45 degrees? Sine 45 degrees is y over 1. So y is equal to the sine of 45 degrees, which is, really? Really? Stop now or you're ahead. What is it? Root 2 over 2. Supposed to memorize them, not be mesmerized by them. Okay, 30 degrees. What's the cosine of 30 degrees? In terms of what we got there. So cos 30 degrees is x over 1. Which means that x is equal to the cos of 30 degrees, which is root 3 over 2. What's the sine of 30 degrees? Which is y over 1, which means that y is equal to sine 30 degrees, which is 1/2. What's the cos of 60 degrees? Noticing anything here? So x is equal to the cosine of 60 degrees, which is And what's the sine of 60 degrees? y over 1, which means that y is equal to the sine of 60 degrees, which is root 3 over 2. Okay, yeah. So, what do we notice? What can you say about x and any of those angles? What's x equal to? Really? Yeah, it says x equals r all over the place there, right? What's x equal to? The cosine of the angle. What's y equal to? Sine of the angle. Yeah, it's kind of interesting, right? The x value, right? So if that's on a unit circle, or if there's a circle there, and this is the radius of 1, you got a point xy. Okay, that point is really cos theta, well in this case cos 45 degrees, sine 45 degrees. Right, so let's take that idea and put it into this. A unit circle is shown below with some points on the terminal arm of angles that are multiples of the special angles 30, 45. Because 60 really is a multiple of 30, right? So really it's 30 and 45. But label the measure of these angles and use your answers from question 4 and symmetry to state the coordinates for each of the indicated points. Okay, so let's... can I make this just a titch smaller? Let's say 75%. Let's try 100%. 100%. That's probably good. All right, so if we take that, let's start with 30. If we take that 30, that triangle with an angle of 30 degrees, well, okay, let's do this one first. What's this? What's the x value for this? Okay, this circle has a radius of 1, right? So how far is the x value? What's the y value? Let's go straight up. What's the x value for this?
0.
What's the y value?
1.
Well, let's go all the way to the left.
A -1.
And let's go all the way down.
0.
There. So those are the quadrantal angles, right? Should we fill them in? What is this angle? 90 degrees. What's this angle? 180 degrees. What's this angle? 270 degrees. Okay. So let's take the 30-degree angle, right? If we put that 30-degree angle here, what are my values for x and y?
1.
Look at your the bottom of the page on the left. What's the x value? 30 degrees.
1/2.
1/2. Really? Try again. Look at the x value for 30 degrees, Mohit. Find the 30 degree.
It's root 3.
Root 3 over 2. Well, what's the y value? 1/2. 45 degrees. Life is easy. They're the same, right? Root 2 over 2. Root 2 over 2. 60 degrees. What's the x value? 1/2. What's the y value? There you go. Even kind of makes sense if you actually look at it, right? To say, well, you know, this is further this way. Root 3 over 2 is bigger than 1/2, right? This is further this way than it is this way. So, you know, putting the half first wouldn't make any sense. Okay, by symmetry, then this point here is this point here. Should we do the angles next? I don't know. What do you want to do next?
First the points.
First the points? Okay, so what happens when this point moves over to here? X becomes negative. So negative root 3 over 2. What about the y value?
Same.
Stays the same. Okay, what about this point? X value becomes negative. What about the y value? Same. What about this point? X becomes negative. I'm sensing a theme. And the same thing with 180, really, right? The x value becomes negative. Okay, what if this point goes down here?
It's like opposite.
X is positive, y is negative. Okay, so this will be root 3 over 2 and negative 1/2. How about for the root 2's over 2?
Root 2 over 2, negative root 2 over 2.
Yeah, so the x values stay the same. And then the same, right? 1/2 negative root 3 over 2. And what happens down in this quadrant? So which one do you want to do? Because we can either take this one down here or take this one over here. Does it matter? No, it doesn't really matter, right? That or this comes across. What's the coordinates here? Negative root 3 over 2 and negative 1/2. Here. And here. Okay, now we're going to need to put some angles on there. Okay, but let's fill that in first. Then I'll show you a really easy way to remember it. And then we'll have all the special angles from 0 to 360, right? Which is really all the special angles in the world, because you could take any other angle and just add or subtract multiples of 360 to find the angle which is coterminal, right? Or get the principal angle for it, and you're good to go. All right, so this angle here has a reference angle of 30 degrees, as does this angle. If the reference angle for this is 30, what's the rotation angle for this? 150. This has a reference angle of, which means a rotation angle of.
135.
This has a reference angle of, which means a rotation angle of. This has a reference angle of 30, giving us, so this angle is 225. And this angle is 240, and this angle is 300, and this angle is 315, and this angle is 330. If only it were 330, we'd be out of here. So there we go. There is your unit circle, which at some point, if not this year, by next year, you're going to have to memorize this thing, right? Not only in degrees, but also in radians, which you don't know right now and you don't have to worry about it. Okay, here's how I remember the unit circle. I need to know 5 numbers. 0 and 1.5 are 3 of those 5 numbers. And I figure 0, 1/2, and 1 are pretty easy to remember. The other 2 are root 2 over 2 and root 3 over 2. Okay, so here's how I do it. I start off by labeling this 1, 0 and this 0, 1. And then I take the y values and I want to count from 0 to 1 using my 5 numbers. 0 and 1, right? So the lowest of those 5 numbers is 1/2. So I go 0, 1/2, root 2 over 2, root 3 over 2, 1. Right? 0, 1/2, root 2 over 2, root 3 over 2, 1. And then I count this backwards. 0, 1/2, root 2 over 2, root 3 over 2, 1. And after that, symmetry takes over and boom, you got the whole circle, right? So that's how I know my special angles, and that's how I memorize the unit circle, right? All I got to do is be able to count from 0 to 1 by 0, 1/2, root 2 over 2, root 3 over 2, and 1. Okay? In any case, you're responsible for knowing it at some point, maybe not this point, but you're responsible for knowing the unit circle, or you're going to have to know it, right? You have to know the trig, the exact values of those special angles. Okay, so let's go back to a full page width. Page width. And scroll down. Recall that for any point xy on the terminal arm of an angle in theta in standard position, that cos theta is x over r, sine theta is y over r. and where r is the distance from the point to 0, 0. Really? And where? How about where r is the distance from the point to 0, 0. For all of the above points on the unit circle, r equals 1 unit circle. Therefore, for each point on the unit circle, cos theta is x over 1 and sine theta is y over 1. Or x is cos theta and y is sine theta. That is, for each point on the unit circle, the coordinates represent the cosine and the sine of the angle. Sorry, I ruined the surprise, right? Because I mentioned that earlier. So if theta is an angle in standard position and xy is a point on the unit circle that is also on the terminal arm of theta, then the point xy is really just cos theta sine theta, right? Okay. Use the fact that tan theta equals y over x to determine the tangent of each of the above angles. All right, so let's go back up and we'll write the tangents next to them. Let's zoom out, zoom in. This will work. Okay, so.
Excuse the interruption.
No.
With the owner of a Pontiac, Montana, CVJ 240, please contact the main office.
Okay, tan is y over x. What's 0 divided by 1? 0. What's a half divided by root 3 over 2? Hint, make life easy, you just need the numerator over the numerator. 1 over root 3, but we don't write it that way, we write root 3 over 3. What's the tan, what's this? Root 2 over 2 over root 2 over 2. 1. What's root 3 over 1? Root 3. What's 1 divided by 0? Undefined. Okay, and then the rest are just, again, symmetrical, except this will be negative root 3, negative 1, negative root 3 over 3, negative 1 divided by 0, 0, y over x. 0 divided by negative 1 is 0. Negative divided by a negative is positive. Positive. Negative 1 divided by 0 is? Undefined. And negative root 3, and negative 1, and negative root 3 over 3. So there's all your tangents, right? Tan is just y over x. Right? Question? Because we don't write 1 over root 3. We just don't do it. Right? We just say, do you see any radicals in the denominator? No. Good. Okay, remember, we rationalize any denominator. So when we look at it and it becomes 1 over root 3, we just do that in our head, right? Really, right? And just say it's root 3 over 3. It's the same as 1 over root 2 is how much? Root 2 over 2, right? And sometimes we want to use the 1 over root 2, right? If I'm dividing by cos 45, I don't want to divide by root 2 over 2 because I'll end up having to rationalize the denominator after I'm done dividing. So I just don't do that, right? I divide by 1 over root 2. All right, let's go up a page. Make it big. Zoom, entire page. Not size, page width. Page width. There we go. Use the unit circle above to state the exact value of each of the following trig ratios. So you remember how we did it the other day, right? We would say, okay, sine of 120, the reference angle is 60, the sine of 120 is equal to the sine of 60 since it's in quadrant 2 and sine is positive. Okay? And that's how I do it to this day, right? But if you have a unit circle, then you can just look at the unit circle. So what's the sine of 120? Root 3 over 2. What's the sine of 315? Get the sine right. Get the sine of the sine. It's negative. I know, I wrote that. It's not what somebody said. What's the sine of negative 90 degrees? Oh, we're going the other way. What's the sine of negative 90?
0.
Seriously?
Negative 1.
Negative 1. What's the sine of 210? Negative 1/2. What's the sine of 270? What's the cos? I'm just writing them down. If you don't agree, you got to let me know. What's cos of 60? 3 over 2. What's the cos of 210? I don't know.
I think it's half.
I'm just writing them down. I said, oh, apparently it's wrong. What is it? 1/2. What's the cos of 210? Negative root 3 over 2. What's the cos of negative 30? Seriously, you going the right way? You have it in front of you. I don't. I can write it out properly. It's not negative because the cosine is positive in quadrant 4 and a rotation angle of negative 30 degrees goes into quadrant 4. Does it not?
Oh, okay.
OMG. Cos 135. You got it in front of you. Yeah, I could fill this all in. I don't even need to look. But what is it? It's cosine of 180. What's the tan of 135? I don't know why I wait for you guys. So I'm not waiting for you guys. The tan of 300. Negative root 3. It's a tan of 90. Undefined. It's a tan of 120. I'm just writing them down, right? What's a tan of negative 360? What's a tan of 585 degrees? Or what's the tan of 225 degrees?
How did you get the tan of negative?
Huh?
How did you get the tan of negative? It goes around in the base.
Oh, this?
Yeah.
You go the other way.
It's just gonna come back to 360.
You're going to come back right to where you started.
Wait, sorry. 360. Well, 360.
All right. What's the cos of negative 315?
Negative 1. Oh, cos.
What?
Root 2 over 2.
Positive root 2 over 2. Because this is the same as what? Same as cos of 45, right? It's a sine of negative 510.
It's gonna be negative.
Really? Don't think so.
No, not mine. How do you get close to negative 350? I just don't understand that. Do you have to go that way?
You can. I just decided to find a coterminal angle and do that.
So we have to go the opposite way, like instead of like just we have to
You can. I chose not to. Negative 315 degrees is coterminal with 45 degrees. So I can work out the cos of 45. All right, what's the sine of negative 510? I keep hearing different numbers. You need to settle on one. What are we going to do with the negative 510?
Subtract 36.
Huh? Subtract 360. Make it more negative. That's good. Let's keep going there. Add 360. Okay, what's negative 510 plus 360? Negative what?
150.
All right, still negative. Then what? Let's add 360. What do we get? 210. So the sine of negative 510 is the same as the sine of 210, which is the negative of sine 30, which is negative a half. What's the tan of negative 150? So we were just there, right? Because then that's 210, negative 150. Negative 150 is really 210. Okay, so what is it? I'm hearing different numbers.
Negative 1.
Still hearing different numbers. Okay, should we convert this to a positive angle? So this is what? The same as the tan of 210, which is in quadrant 3, where the tangent is positive, and is the same as the tangent of 30, which is root 3 over 3. It's cos of negative 270, because it's the same as the cos of 90. Okay, so that's how you use your unit circle, right? You got everything on there, you just have to rotate correctly. I chose to go to positive angles just because I don't actually have the unit circle in front of me, right? So then I need to go to positive angles. I still generally tend to use the idea of reference angles and the cast rule, because then I really only need to know the first quadrant of the unit circle, right? Because I turn everything into a reference angle, go back to that first quadrant, get the angle, determine whether it's positive or negative based on the cast rule, and there's my answer. And I don't have to draw out a whole big unit circle, right? I only have to draw a quarter. And that's easy, right? Because you go 0, a half, root 2 over 2, root 3 over 2, 1, and you go 0, a half, root 2 over 2, root 3 over 2, 1. That's it. That's all you need. First quadrant of the unit circle, reference angles, the cast rule. Is that how you do it? Yeah. That's how you do it. Solve each equation for theta, where theta is between 0 and 360. When is cos theta equal to root 3 over 2? When theta is? Here's another way to ask it. Go around your unit circle and let me know every place that x is root 3 over 2. 30 degrees. What else? So 30 degrees and 300, and would that it were only 330. But. Okay. Cos of theta is negative a half. When? Remember, we're between 0 and 360. What's the first one? 120 degrees. What's the second one? Sorry? Sorry? 240. Thank you. Somebody said that. Then somebody was saying 225. And I'm like, really? When is the sine of theta equal to negative root 3 over 2? When theta is? 300. What else? Let's go low to big to small. What's the small? Or small to big. What's the smallest one? 240 degrees and 300 degrees. When is the sine of theta equal to 1 over root 2? Trick question, 1 over root 2. It's root 2 over 2. So when is this? 45 and? Keep looking, you'll find it. 45 and?
315.
Seriously? God, can I bang my head against that? Sine theta is positive, right? Positive. The cast rule tells us that every trig ratio is positive in how many quadrants? 2, and it's negative in 2. So each of these are going, as long as they're not quadrantal angles, right? That could be a little bit different. Non-quadrantal angles, each of these things are going to have how many answers? 2. If sine theta is positive, I know it's quadrants 1 and 2. If sine theta is negative, I know it's 3 and 4. If cos theta is, I don't even know what that was. If cos theta is negative, I know that's 2 and 3. If cos theta is positive, I know that's 1 and 4. Learn your cast rule. Tan theta is negative 1.
275.
Just 270?
175.
Yeah. Okay. How did you get 270? Where's tangent negative? Quadrant 2, quadrant 4. How do you end up with a quadrantal angle? I don't know. Tan theta is √3. Positive. Quadrant 1 angle is 60. Quadrant 3 angle is 240. Hopefully that's it. Oh, that's it for that one anyway.